Okay, so get this. You send in a guide on SQL syntax mastery, hoping to decode this whole SQL thing, right? And it turns out you submitted it on the exact day it was published, October 5th. Talk about serendipity. What are the odds?
It seems we were destined to have this conversation. And trust me, understanding SQL is like having a backstage pass to the world of data. Especially now with the amount of data exploding, it's the common language for all these relational databases, no matter the industry.
The guide calls it as fundamental to data as HTML is to web pages. Even quoted tech guru Tim O'Reilly on that point. But it's not just about displaying information anymore, right?
Exactly. It's way bigger than that now. Think about how big data and cloud computing have taken over. We're talking massive data sets, distributed systems, the whole shebang.
Mm.
SQL's set-based approach, where you're working with entire sets of data at once, makes it incredibly efficient for that world. It's a different mindset than traditional step-by-step programming. And that's what makes it so powerful for things like Hadoop with Hive or cloud platforms like Redshift and BigQuery. They all rely on this language that's been fine-tuned for decades.
Which is wild considering the guide mentions SQL originated in the 70s. You're telling me it's been powering databases since Disco was king?
And just like Disco, it's had its evolutions. Became the ANSI standard in '86, then ISO a bit later, but it didn't stop there. SQL 92 and later versions added all sorts of cool stuff, object-oriented features, XML support things I'm sure would make your life easier down the line.
Mhm.
It's constantly being refined while staying true to its core, which is probably why it's more relevant than ever.
Talk about adapting to the times. Now let's talk about the actual language. I'll confess, when the guide dove into those building blocks, keywords, identifiers, clauses, all that, it felt a little like deciphering a foreign language.
It is a language, in a way, but think of it like this. SQL syntax is like grammar. Once you grasp the rules, you can construct powerful queries to extract meaning from data. Remember that example. Select employee, first name. Right? Each part plays a specific role, just like words in a sentence.
Right. So employee, first name, those are like the nouns, the things we're interested in. And select is our action verb telling SQL what to do.
Precisely. And once you've got those basics down, you can start building more complex queries, combining them, filtering them. It's like going from simple sentences to writing a whole novel with data.
And I'm guessing that's where those different data types come in. The guide mentioned it's not just about text and numbers. There are dates, booleans, even timestamps. Honestly, never thought about needing a specific type for a timestamp.
It's about choosing the right tool for the job. Imagine trying to cram a giant birthday cake into a tiny lunchbox. Not going to end well, right? Data types are about making sure the container fits the data. Choosing the wrong one can really hurt your database's efficiency later on, especially when you're dealing with massive amounts of information.
So it's not just about storing data, it's about storing it smartly. Makes sense. But then the guide throws another curveball acronyms. DDL, DML, felt like I was back in school cramming for a vocab test.
Don't worry, no pop quizzes here. Think of those acronyms like categories in a library. DML, or Data Manipulation Language, that's where the action is. Select, insert, update, delete the verbs that let you interact with the data itself.
And speaking of verbs, the guide calls select statements the heart of SQL queries. Sounds pretty vital.
It is how you retrieve data, the most fundamental operation in SQL. Imagine you're in a library and you need to find books on a specific topic. The select statement is like your search query. It lets you specify exactly what you're looking for.
Okay, that clicks. The guide breaks it down into select, from, where. Seems simple enough, at least at first glance.
And that's the beauty of SQL. It can be surprisingly elegant in its simplicity. You're telling SQL what data you want, from which table, and any conditions that apply. For example, let's say you were interested in all the customers in the system from a particular state, maybe your home state. A select statement is how you'd pull that information.
Right. You'd select the customer name and maybe their city from the customer table, but only where their state matches yours.
Exactly. You're a natural at this. See, SQL isn't about memorizing complex code. It's about understanding the logic, the flow of how you ask questions to get the data you need.
Okay, I'm feeling good about this. Now, about those joins the guide mentioned, they sound kind of crucial, especially that interactive join visualization. That sounds cool.
Joins are where things get really interesting, because in the real world, data is rarely confined to just one table. You've got customer data in one, their order history in another, maybe product information somewhere else. Joins let you connect these separate tables, like piecing together a puzzle.
So instead of just seeing a list of customers or a list of orders, I could use a join to see who ordered what all in one go.
Exactly. And there are different types of joins for different scenarios. But the most common one, the one you'll likely use most often, is the inner join. Think of it like finding the overlap between two circles. You only get the data that exists in both tables, based on a shared column.
All right, so we've got the basics down. We can find data, filter it, even combine information from different tables. It's like we're building our own SQL toolkit.
Exactly. And just like any good toolkit, SQL has some power tools that can really amplify what you can do. That's where views, stored procedures, and functions come into play. They're like taking your SQL skills to the next level.
The guide mentioned those, and honestly, they sounded a bit intimidating. Like pro-level SQL.
More like time-saving shortcuts. Think of them as building blocks for your building blocks. Instead of writing the same complex queries over and over, you can create reusable components. Let's start with views. They're like virtual windows into your data.
Virtual windows, so not actual tables.
Right. They don't store data themselves, they're more like pre-saved queries. Let's say you frequently want to see all orders placed in the last month. Instead of writing that query every time, you create a view that essentially says, this is what the data should look like.
So it's like having a custom report always ready to go.
Exactly. And you can use views in other queries too, just like regular tables. But here's the cool part. They can also act as a security measure. You could create a view that only shows certain columns from a table, protecting sensitive information.
It's like giving someone a limited access pass to your data. They only see what they need.
Precisely. And that can be incredibly valuable, especially when you're dealing with data privacy and access control. Plus, if the underlying table structure ever changes, you might only need to update the view. Not every single query that used that data. Talk about a time saver.
Okay, views are officially on my SQL to learn list. They sound incredibly handy. Now, stored procedures, the guide, made them sound like some kind of SQL superpower.
They're all about efficiency and automation. Imagine you have a series of tasks you need to do regularly in your database. Say, adding a new customer. This might involve updating multiple tables, checking for duplicates, even sending a welcome email.
Yeah, that sounds like it could get messy and repetitive writing all that SQL every time.
Exactly. With a stored procedure, you package all those steps into one reusable unit, give it a name, and boom, it's like having a custom SQL command. And since they're precompiled, they often run faster too, because the database knows exactly what to expect.
So, more efficient and less typing, I'm sold.
And there's more. Stored procedures can help with security too. You can control access to them separately, so maybe only certain users have permission to execute specific procedures. It's another layer of control over your precious data.
Okay, definitely adding stored procedures to the must-learn list. Now, functions, how are they different from stored procedures? They sound kind of similar.
They both package SQL logic, but functions are like those handy calculator buttons. You use them when you want to get a specific value back. Maybe you need to calculate the total value of an order, including tax, or you want a function to format dates in a specific way.
So functions are all about calculations and returning a result, whereas stored procedures are more about actions and updates.
Exactly. Think of functions as your go-to for custom calculations and data transformations. And just like with stored procedures, they make your code more readable and reusable.
This is really making me appreciate how versatile SQL is. It's not just about retrieving data, it's about building custom logic, automating tasks. It's like a programming language in itself.
You're getting it. And just like with any programming language, security is paramount, especially when you're dealing with sensitive information. The guide seemed to stress that point too.
Yeah, and for good reason. Data breaches are a constant worry these days. So how does SQL stack up on the security front?
It's got your back. SQL has built-in security measures that act like a fortress around your data. It's not just about keeping hackers out, it's also about making sure the right people have the right access within your own organization.
So it's like having different levels of security clearance.
Exactly. Think of it like this. You have user accounts, which are like individual keys, and then you have roles, which are like key cards that grant access to certain areas. You wouldn't give everyone in your company a master key to everything, right?
Definitely not.
Well,
So how do those roles and permissions actually work in SQL?
it's all about control. You could define different roles like read-only for analysts who just need to view data or editor for those who can modify it. Then you assign those roles to specific user accounts.
So if someone changes roles or needs different access, you can just update their permissions without messing with their whole account.
Exactly. It's all about granting the minimum access necessary for someone to do their job. That's the principle of least privilege. This way, even if one account is compromised, the damage is limited.
Okay. That makes sense. Minimize the blast radius. So strong passwords, roles, permissions. It sounds like SQL has a pretty solid security system in place.
It does, and it goes even further. SQL offers things like encryption for your data, audit trails to track who did what, and you can even integrate it with external security systems.
Wow, it's like SQL has its own security detail.
In a way, it does. It's up to the people setting up the database to make sure those security features are configured correctly and that best practices are followed. But the tools are there.
That's reassuring, to say the least.
Yeah.
Now, I remember the guide also talked about how SQL isn't just for those traditional databases anymore. It's popping up in all these modern data environments.
Absolutely. SQL's like that versatile actor. It can play any role. It's just as comfortable with big data, cloud platforms, and even those NoSQL databases that are all the rage these days.
So, no matter where data lives, SQL can find a way to work with it.
Pretty much. It's become a lingua franca for data, bridging different systems and technologies. Remember how we talked about SQL being great for big data because of its set-based approach? Well, frameworks like Hadoop, which are designed for handling massive data sets, often rely on SQL-like languages like Hive for querying that data.
So even though the data might be spread out across a whole cluster of machines, I can still use SQL to make sense of it.
Exactly. And it's not just Hadoop. Cloud platforms are also embracing SQL in a big way. You've got services like Amazon Redshift and Google BigQuery fully managed SQL databases in the cloud. It's like having a high-powered database at your fingertips without the headache of managing all the hardware.
It's like SQL on tap. So even with all these new technologies, SQL is more relevant than ever.
Absolutely. It's not just surviving, it's thriving. And it's not just that SQL is being used everywhere. The language itself is evolving too. New features, new syntax SQL is constantly being refined to meet the demands of the ever-changing data landscape.
The guide mentions something about pipe syntax and AI integration. Those sound pretty futuristic.
They're definitely pushing the boundaries of what's possible with SQL. Pipe syntax is all about improving readability, especially for those really complex queries. It uses a more intuitive, chain-like structure, making SQL code easier to write and understand.
So it's like streamlining the SQL language itself, making it more user-friendly.
That's the idea.
Yeah.
It's still in its early stages, mainly supported by Google SQL and a few others, but it reflects a trend of making SQL more approachable, especially as data analysis becomes more collaborative.
Well, hopefully by the time I'm fluent in regular SQL, pipe syntax will be everywhere. But what about the AI integration? What's that all about?
Now we're talking about next-level stuff. Imagine asking your database complex questions in plain English, and it not only understands you, but can analyze the data and make predictions based on what it finds.
Whoa. So instead of me writing all these complex queries, I could just ask the database.
That's the dream. And platforms like Google BigQuery ML are already making it a reality. You can use SQL to build and train machine learning models directly within your database.
So I could potentially predict things like customer churn or product demand all within SQL. No need to learn a whole separate programming language.
You got it. It's all about making those powerful AI capabilities accessible to SQL users. And the applications are endless. Imagine using your database to forecast sales, optimize marketing campaigns, even personalize user experiences, all based on real-time data analysis and AI-powered predictions.
Okay, that's seriously impressive. It sounds like we're on the verge of a SQL revolution. But before we get too far ahead of ourselves, I'm curious, with all this talk about the future of SQL, are the fundamentals still important?
Absolutely. It's like learning to walk before you can run a marathon. Those core SQL concepts, select, from, where, joins, understanding data types, they're the building blocks for everything else. You can't build a skyscraper on a shaky foundation.
So as excited as I am about the future of SQL, I shouldn't get ahead of myself. Master the basics first, then explore the fancy stuff.
Exactly. And the good news is there are tons of resources out there to help you build that foundation. Online tutorials, courses, books, interactive sandboxes where you can write your own queries. You have the world of SQL at your fingertips.
I've even heard of certifications that can demonstrate your SQL prowess to potential employers.
Those can be helpful, especially if you're looking to specialize in a particular database system or industry. But more than anything, it's about practice, practice, practice. The more you use SQL, the more intuitive it becomes.
Right. It's like learning a musical instrument. You have to put in the time and practice to become fluent. But before we wrap up this part of our deep dive, I think there's one crucial aspect we haven't covered yet: error handling. Because, let's be honest, no one writes perfect SQL code on the first try.
You got that right. Errors are like those unexpected guests. They show up at the worst possible time. And just like dealing with unexpected guests, learning how to handle SQL errors gracefully is a must-have skill.
All right, diving back into the world of SQL, we've covered so much ground already, from the basics to some seriously powerful tools. Now, I'm ready to tackle those future of SQL topics we touched on earlier, especially that pipe syntax thing. It sounds like a total game changer for readability.
It's definitely shaking things up. Imagine writing SQL queries that actually look like the logical flow of data transformations. Instead of that dense nested structure we're used to, pipe syntax uses the pipe symbol, that's this guy, to chain operations together.
Okay, that sounds way more intuitive. So instead of jumping between select from where clauses, it's more like take this data, then do this, then do that.
Exactly. Each step feeds into the next, making it much easier to follow the logic, especially for complex queries. Remember that example we had before, finding the top-selling products in a specific category over the last quarter. It involved multiple joins, a where clause, grouping, sorting the works.
Yeah, it was a mouthful. Even knowing a bit of SQL now, it still looked pretty intimidating.
Well, imagine that same query, but written in pipe syntax. You'd start by taking the orders table, then joining it with order items, then products, filtering along the way, and finally selecting the data you need. It reads more like a recipe than a jumbled up code block.
Wow, that's way easier to wrap my head around. It's like the difference between trying to follow a map with lines going everywhere versus a set of clear directions. But is pipe syntax part of the official SQL standard?
Not yet, but it's gaining traction. Google's using it in BigQuery and their Zeta school language. Other database systems are experimenting with similar approaches too. It really reflects this larger trend of making SQL more approachable and collaborative, especially as data analysis becomes increasingly important in all sorts of fields.
So definitely something to keep an eye on. Now, on to something even more futuristic, AI integration. We briefly talked about this earlier, but I still have so many questions.
It's a game changer. Imagine asking your database questions in plain English, like, what were my best-selling products last month? And instead of just giving you raw data, it analyzes the information and gives you insights.
That's amazing. It's like having a data analyst built right into your database, but how does that actually work? Is there some sort of AI magic happening behind the scenes?
It's not magic, but it's pretty close. Platforms like Google BigQuery ML are already paving the way. They let you build and train machine learning models using SQL. That's right, you can actually do data science within your database.
So I could potentially create a model that predicts customer churn or product demand all using SQL. No need to learn a whole separate programming language.
You got it. It's all about making those powerful AI capabilities accessible to SQL users, and the applications are endless. Imagine using your database to forecast sales, optimize marketing campaigns, even personalize user experiences, all based on real-time data analysis and AI-powered predictions.
Okay, this is blowing my mind. It sounds like SQL is becoming the ultimate data superhero. But with
Okay.
all this talk about futuristic syntax and AI integration, are the fundamentals still important?
Absolutely. It's like learning to walk before you can run a marathon. Those core SQL concepts, select, from, where, joins, understanding data types, they're the building blocks for everything else. You can't build a skyscraper on a shaky foundation.
So, as excited as I am about the future of SQL, I shouldn't get ahead of myself. Master the basics first, then explore the fancy stuff.
Exactly. And the good news is there's a wealth of resources out there to guide your learning journey. Online courses, tutorials, interactive platforms where you can write and test your own SQL code. You even mentioned certifications earlier, which can be a great way to showcase your SQL skills to potential employers.
It's reassuring to know that even though SQL is constantly evolving, those fundamental skills will always be valuable.
Absolutely. And as you become more comfortable with those basics, don't be afraid to experiment, to push the boundaries of what's possible. Try new things, break some queries. It happens to the best of us. And most importantly, have fun with it. SQL can be incredibly rewarding, opening up a world of possibilities for understanding and leveraging the power of data.
This has been an incredible journey. We've gone from deciphering SQL syntax to discussing its role in shaping the future of data. If you're just starting out with SQL, what's the one key takeaway you would leave our listeners with today?
Embrace the learning process. SQL can seem intimidating at first, but with the right resources and a healthy dose of curiosity, anyone can unlock its power. Don't be afraid to get your hands dirty, write some code, make mistakes, and watch as you gradually gain fluency in this incredibly valuable language.
I couldn't have said it better myself. And on that note, we're wrapping up this deep dive into the world of SQL. We've covered so much ground today, from those essential building blocks to those mind-blowing future trends. It's been fun, and I've learned a ton. Thanks for joining me on this SQL adventure.
It's been a pleasure. And remember, the journey of SQL mastery doesn't end here. Keep experimenting, keep learning, and keep exploring the endless possibilities of data.
And to all our listeners out there, happy querying.